All right, in this video we're going to look at the three laws of thermodynamics, three of the most important laws in science. Um, so thermodynamics means kind of the movement of energy, the movement of thermos, like heat. We've got three basic laws that you need to have remembered, and we'll remember them in a simple way. So, law number one, energy can neither be created nor destroyed, it can only change forms. Right? You have energy in a car that's traveling, but where did the car get that energy? From the gasoline. Chemical reactions from the gasoline. The entropy, we're going to look at this word, of an isolated system not in equilibrium will tend to increase over time, approaching a maximum value at equilibrium. It's kind of complicated. We'll get to simple examples. As temperature approaches absolute zero, the entropy of a system approaches a constant minimum. All right, so law number one. If reactions can be exothermic or endothermic, then where did that change of energy come from? Remember, equations are balanced. There are the same number and type of atoms on the products as there are in the reactants. For example, if methane burns and releases heat energy, that heat energy must have come from somewhere. Well, in chemical reactions, it comes from the chemical bonds. Forming chemical bonds takes energy from the atoms and puts it into the environment. Forming chemical bonds takes some energy from the atom, puts it into the environment. So that's law number one. Law number two, everything wants to reach its lowest energy state. So everything kind of winds down. Bottled up energy is never stable. It will be released somehow. Consider what happens if you open up a pop bottle and leave it on the counter overnight. Does it taste the same the next day? No, because gas particles inside of it, they were put in there with some energy. They had extra energy. They left until they reached an equilibrium. Put food coloring in water. Does it stay in one place? No, it uniformly distributes through the liquid. It reaches an equilibrium. Once it's at the equilibrium, that's kind of the lowest energy state it can get to. These are all forms of entropy at work, a level of randomness. Things naturally move towards the highest level of randomness disorder, or the lowest amount of bottled up energy. Law number three. As things get colder, closer to negative 273.15 degrees Celsius, particles slow down. When the particles slow down, they are not able to react or interact with each other as much. It is not possible to slow down all particles of a system to zero and thus have no entropy. Absolute zero cannot be reached. So, number one, energy can't be created or destroyed. It only changes forms. Number two, everything tries to get to its lowest energy state. Doesn't try, everything goes to its lowest energy state. It may not happen instantly, it may take a while. Number three, nothing can get to zero. Those are the 3 laws of thermodynamics. One of the consequences of thermodynamics is that if you want things to stay in a highly ordered state, you have to constantly be putting energy into it, because things have a tendency to get to their lowest energy state. You can think of a high energy state or a high entropy state So a low entropy state. Let me just make sure I'm doing this right in my brain. Yep. A low entropy state. A low entropy state is like a clean room. It's very organized. Now, if you don't put any work into that clean room, that room will naturally become a mess and the entropy will increase. I said that wrong. I said that wrong. High entropy is ordered, low entropy is chaotic. Just remember that. High entropy is ordered like a clean room, low entropy is chaotic like a messy room. If you want to go from low entropy to high entropy state, you need to add in some energy. You need to put some work into it. So high entropy is an ordered, but everything tries to get to its lowest energy state or its lowest entropy level. That's a little confusing. I hope you kind of got it. Just remember these 3 rules. These 3 rules will be asked of you on quizzes and tests.